अच्छा चलिए स्टार्ट कर लेते हैं कि लास्ट टाइम we did this thing. I talked about Gibbs free energy. जिसमें क्या था? Gibbs free energy is when it's the overall energy that's available to a system. ठीक है? So a system produces work in two ways. It produces heat and it produces disorder, which is work that is produced due to disorder. Heat क्या होती है? That's enthalpy change. Work that is produced due to disorder is basically entropy multiplied by temperature. ये हमने we figured out this formula early on. जब हमने I told you entropy change was what? Entropy change was the work that is produced at a particular temperature. So the work that gets produced is basically minus T times delta S. If I rearrange everything, work produced at a particular temperature. So T multiplied by delta S is the work produced. And so I told you that the overall energy that's available to a system is this, plus it's this. You add them up, दोनों को add करो, तो आपके पास ये आ जाता है. That's the total energy that's available for work. Agar if this comes out to be negative, then that means it's feasible. That means the system is going to release energy overall. That means no external work is needed. Agar positive aata, that means work is required. Hence, no reaction will happen. As we started figuring out how to predict whether a reaction is feasible or not feasible. Okay, so we did some examples. Okay, if I want to boil water, I know that it's feasible at higher temperatures. So delta H for this reaction is positive endothermic. Delta S for this reaction is also positive because disorder is getting created in this reaction. Now, if one of them is positive, the other one is also positive. So the expression would, because of this negative sign, this side would actually become negative. So if I want to make delta G less than 0, I want to make it exothermic. So I would have to keep the negative term large. How do I make it large? I would try to keep T as high as or large as possible. I'll do another example. Petrol car, okay? So we'll do another example. Combustion of petrol, right? Combustion of octane. Okay, let's do this example. So octane is what? It's C8H18. We're going to try and burn it. So I want to know whether this is a feasible reaction or not a feasible reaction. So it's going to produce what? It's going to produce carbon dioxide and water. And there's going to be 8 carbon dioxide molecules and there's going to be 9 water molecules. This one, let's say, is a liquid. Oxygen is a gas. It's 8 times 216 plus 9. That's 25 oxygens. So 12.5 oxygen gas molecules. And on the other side, you're going to get 8 carbon dioxide gas molecules, and it's happening at a higher temperature. When you burn it, it's obviously at a higher temperature. So this is also gas. Now you can clearly see that the enthalpy change for this reaction, it's an exothermic reaction. The enthalpy change is negative. Iski entropy change kya hai? Is it positive or negative? What is it? साथ क्या है इसकी entropy change? Disorder, is it increasing or decreasing? More gas or less gas?
Increasing, sir. It's becoming positive.
Okay, so there's more gas being produced, so it's positive, right? So I want to know okay, when this reaction will be feasible, right? So when this reaction will be feasible, delta G is what equal to delta H enthalpy change and the work that is produced due to entropy change. So now delta H happens to be negative, and your delta S happens to be positive. Now, because of the negative sign, this side is also negative. So that means both terms happen to be negative. And that would indicate that it's always feasible. So hence your delta G would always be exothermic, less than 0. Hence this reaction is always feasible. So burning petrol is a very feasible reaction, whether you do it at minus 100 degrees centigrade or at 1000 degrees centigrade. This reaction will always be spontaneous. ठीक है, so I can अच्छा ये समझ आ गया ना कि by finding or by looking at the signs of delta S and delta H, you can figure out when your delta G would be less than 0, right? Is that clear? Arun, clear? The theme is this clear?
Yes, sir.
Yes, sir.
So I can now make a table. The table is I mean it's the so I'll have my signs of delta H. I'll have a sign of delta S, and I'll predict what the sign of delta G is going to be. So if, and this is my relationship, which is that delta G is equal to minus T times delta S. So if both of them are positive, so this is positive, that makes this negative. So when will delta G be negative? When you keep the negative term bigger. So temperature has to be high. So delta G would be less than 0 at a higher temperature. As a second, what if this is positive and this one is negative? So if the first one is positive and the second one happens to be negative, because of the negative sign, this side would also become positive. So that means delta G is never going to be less than 0. So that means it's never spontaneous, never feasible. You clear? Is this part clear? The question
Yes,
is, so then you have the first one is negative and delta S happens to be positive. So if I rub this off, the first one is negative. Delta S happens to be positive. Because of the negative sign, this is also negative. So that means both terms happen to be negative. So that means delta G would always be less than 0. So that means it's always spontaneous no matter what you do. Finally, the last one is that what if both of them are negative? Then this, if both are negative, then this side would actually be positive. So if I want to keep delta G negative, that means I would have to have a lower temperature. I would have to have a lowest positive term. So delta G would be less than 0 at a lower temperature. You clear that all your reactions can be divided into these four scenarios, and this would help you predict whether a reaction is spontaneous or not spontaneous. ठीक है, क्लियर है?
यस सर।
Yes, sir.
और ये ऊपर मिसाल लिखे हुए हैं। तस्लीम, ये क्लियर है? हारून, इज दिस क्लियर? बट वी डिड एग्जांपल्स।
यस सर।
ठीक है। अच्छा, नाउ द नेक्स्ट थिंग. The next question I told you was your quantitative question where they'll just give you values. You just plug those values in, and that's it. Okay, so you'll find out the value of delta G. Now, there's one very specific question that they're going to ask you, and that is find the temperature at which a reaction becomes spontaneous. Becomes spontaneous or feasible. So that means if it wants to be spontaneous, delta G has to be less than 0. Delta G is basically equal to delta H minus T delta S. So that has to be less than 0. So you just have to solve for this inequality. So they're going to ask you about when, at what temperature does a reaction become spontaneous. You just solve this inequality. Okay? You be clear? Is this part clear? This one?
Yes, sir.
Okay, so you just have to figure out when your delta G becomes less than 0. So we're going to start doing questions related to, just a second. Second, let me get rid of this. Okay, we're done with entropy change. So we're just going to do just let me get rid of this. So starting with the first question, okay? Starting with the first question, just very, very quickly. He's asking you to calculate delta S for the reaction. So delta S for the reaction is your product entropies and minus your reactant entropies. So okay, what is your product? Your product is SiHCl3. That's ये जब कोई जल्दी से calculator में calculator 314 plus H2 is 131. That's my product minus my reactant, which is what Si, which is 19 plus 3 HCls. That's 187 times 3. अच्छा, अगर क्विकली क्या वैल्यू आ रही है इसकी?
Sir, negative 135.
We're getting negative 135, and the unit is for entropy changes joules per Kelvin per mole. That's the next part of the same question. He's now given you the enthalpy change. He says use the information in your answer to B1 to calculate the temperature in kelvins at which the reaction 3 becomes spontaneous. So if you want it to become spontaneous, that means the delta G should be exothermic, should be less than 0. And delta G is equal to delta H minus T delta S. So that means delta H minus T delta S must be must be less than 0. So I need to just solve for this. The enthalpy change is already given. That's 219.3. The temperature is unknown. The delta S for this reaction was calculated in the previous step. It was what? It came out to be minus 135. So the delta S for this reaction is going to become plus 135. और उसकी reason मैं बता दूं कि why is it plus 135? Because this reaction, like if I zoom out, and the reaction that they were talking about earlier, ये वाला, they're exactly opposite of each other. Silicon and 3HCls are on the left side, whereas over here silicon and 3HCls are on the right side. So if you go in the backward direction, the entropy change sign reverses. Okay? Is this clear? Why I'm reversing the sign of entropy change? Is it clear?
Yes, sir.
Yes.
And I just have to solve for this, so it's should be less than 0. So one very important thing about this is that enthalpy change is in kilojoules, while entropy change is in joules. यहाँ पे unit भी देख लो, ठीक है? This is in joules, and your enthalpy change is in kilojoules. So make sure you either keep all of them in joules or all of them in kilojoules. So I'm going to convert the kilojoules into joules by multiplying it by 1000. And then I'm going to try and solve this. So if I try and solve this, it's going to be 219.3. And on the other side, you're going to have T times 135. 135 goes to the other side. So, okay, what do you get? What is the value for temperature?
One 1624.
Is there
1624.
1624. So that's your calculated temperature in calories at which the reaction C becomes feasible. That's 1624, or any temperature that's greater than 1624. Okay, clear? That's a simple application of Gibbs free energy. Is this Saad? Is this clear, Beth? Harun, Tasneem, is this clear?
Yes.
Okay, now as I explained what is meant by the entropy of a system, it's the measure of a disorder of a system. NaCl dissolving in water, that's positive. More dissociated aqueous ions are produced. Water solidifying to ice, that's negative. This ice has more ordered particles. So now this one. Now this one is slightly a tricky graph. He's saying that the evaporation of 1 mole of water has a standard Gibbs free energy of 8.6 kilojoules at 25. So that means at 25 centigrade, the delta G is 8.6, positive 8.6. So this is, so this is positive. So this is your positive 8.6 on the graph. Now sketch a graph on the axis to show that how delta G changes for this process between 25 and 150 at 101 kilopascals. That's room conditions. But the temperature is increasing. As a first thing, at what temperature does the evaporation of 1 mole of water become feasible? The constant temperature at which evaporation of 1 mole of water becomes feasible. What's
100?
100 centigrade, right? So any temperature that's above 100
Yes.
or equal to 100, right? evaporation of water becomes very feasible. So if it's becoming feasible, so at this temperature, delta G must be less than 0. So that means at 100 or after 100, after this point, your delta G becomes less than 0. Before that, it's not feasible. At 50, evaporation is not feasible, 75 not feasible, but at after 100, it is feasible. Okay, so the line would be like this. Before 100, it's not feasible, so it's going to be positive values. After 100, it's feasible, so it's going to be negative values. Okay? Is this clear, this question? ये सारों को clear है?
Yes, sir.
बाकी yes or no? सार clear है?
Yes.
ठीक है. अच्छा वो ये part तो clear था कि like you had 100 degrees centigrade, right? Before 100, it's not feasible, so delta G has a positive value. After 100, it's very feasible, so it's got a negative value, right? Why do you think it has a straight line? It could have been a curve as well, right? How are you sure that this line is a straight line?
Is it based on the equation, sir?
What's the equation? Delta G is equal to what? Delta H minus T times delta S, right? So what exactly are they plotting? They're plotting delta G, which is on the y-axis, and they're plotting temperature, which is on the x-axis, right? So your equation has now turned into a straight line equation. This is your y. This is your delta H minus this is your x times delta S, right? Now, if I compare it with y is equal to mx plus c, right? X at all, that's right. So if I compare it with y is equal to mx plus c, what do you think in a straight line equation? Okay, hopefully you've done this in physics. What does delta S represent in this equation? Like
The gradient.
Okay, that's your gradient. Okay, mx. Okay, x के साथ whatever is next to x, that's your m. That's your gradient. So the gradient of this graph, although they did not ask for it, but the gradient of this graph is your delta S. And what is delta H over here?
Y-intercept.
Okay, so that's
C.
that's C. That's your y-intercept. Okay, ये तो आता है ना सारों को, like you can compare it. So it is a straight line equation. You don't have a straight line if you can't put an equation this form. If you had a square or something like that, and you could not arrange the equation in this form, then you're never going to have a gradient. That's your y-intercept, delta G plotted against temperature. The gradient is your entropy change. I say you a question. The reaction between A and B is feasible at low temperatures, but is not feasible at high temperatures. So you have to predict delta H and delta S signs. So feasible at low, not feasible at high. I can just look at the table. So feasible at low. So that means delta G is less than 0 at lower temperature. So it's this one. So this is the only one. So that means both of them are going to be negative. ठीक है, तो ये clear है कि table के अंदर this is the combination that's going to work. Is that clear?
Yes, sir.
Yes.
Yeah.
So both of them are going to be negative, right? So, and then you can justify it. Like you're going to write that delta G is what? Delta H minus T delta S. Now your delta H happens to be negative, and your delta S also happens to be negative. So that makes the whole term positive. Now, if I want delta G to be spontaneous, if I want it to be less than 0, exothermic, I would have to keep the endothermic term small. And the only way is that it's going to be spontaneous at a lower temperature. So that's when delta G, so at lower temperatures, T delta S becomes smaller. And hence your delta G comes out to be less than 0. Okay, so is that clear?
Yes, sir.
Just similarly, let's do the next one. See, यहाँ पे भी ना we did earlier calculate delta S for this reaction, right? Delta S is already given. इसका फिर से एक दफा quickly calculate delta S. Product minus reaction. So it was what? 192 divided by 2 plus O2, which is 205 divided by 2 plus half I2, which is 261 plus 2H2O, that's 2 times 70 minus my reactant, which is 42. अच्छा क्या क्या आ रहा है इसका delta S?
427, sir.
Hmm?
427.
And it's joules, it's in joules, right? So it's positive, right? And we could have
Yes.
guessed that it's positive because you got a lot of gases produced in your products, right? So it is positive. And delta H is negative. So let's go. So delta H is negative, and your delta S happens to be positive. TK, we just calculated the value of delta S. So he's saying prove that it's feasible at all temperatures. So delta H negative, delta S positive. TK, we just so delta. So which one is feasible at always spontaneous? It's this one. Delta H negative, delta S is positive. So you're going to justify it in the same way. You're going to write delta G is equal to delta H minus T delta S. This is negative and this is positive. But because of the negative term, sign, this one also becomes negative. So you're going to write that at all temperatures, minus T delta S has a negative value. And your delta H also is negative. Hence, it's always spontaneous. Is that clear?
Yes, sir.
So अब है कि let's do. So give the full name for the term delta G, that's your Gibbs free energy. Describe how the temperature at which the reaction becomes spontaneous can be calculated. Include an equation in your answer. So you just have to tell them that delta G is equal to delta H minus T times delta S. You're going to tell them that for spontaneous or feasible reaction, your delta G's got to be less than 0. So delta H minus T delta S should be less than 0. And then you solve for T. That's it. So over here, he's asking calculate the entropy change for the reaction at 298 Kelvins. For the reaction, these values are given. So delta G is given, that's minus 102. So delta G is equal to delta H, which is minus 195, minus T, which is given, and it should always be in Kelvins, that's 298, times delta S. So make delta S the subject of the equation, it's going to be you're going to divide it by minus 298. क्या आ रहा है इसका?
Sir, negative 0.310.
And what's the unit, joules or kilojoules?
This one's in kilojoules, sir.
Kilojoules.
ठीक है, so it's kilojoules per mole. Kilojoules per mole, ठीक है. State whether the delta S sign agrees with that predicted. You got a negative entropy change, right? Negative means disorder is decreasing. So does it agree or not? I think,
Yes, sir.
but this is the balanced equation, right? 2 N2 is 2 N2, so that's 4 NO, that's 4 oxygens, 1 oxygen over here, 3 over here, so it's balanced, right? So why does it, so it's, the disorder is decreasing, you get fewer gas moles, right? Hence your delta S is less than 0. He's asking me to enthalpy change is given. Let's calculate delta S for this reaction. So delta S is so your product is 2 PBO, that's 69 times 2, and O2, that's your other product, so that's 205. Minus your reactant, which is 2 PbO2, that's 77 times 2. Acha, kitna hai? What's your delta S for this?
189, sir.
189.
Acha, 189 aa gaya. And then he's asking calculate the value of delta H. Use the value of delta H. Find the temperature at which this reaction becomes spontaneous. So delta G has to be less than 0. So that means delta H minus T delta S must be less than 0. Delta H is given, that's 118 kilojoules. So I'm going to convert that into joules. Okay, I want to keep the unit consistent. So temperature, I don't know. My times what delta S. Delta S is calculated as 189. So this entire thing has to be less than. So it's going to be 118,000 divided by 189. You got it. So just try and find the answer for this one.
624.
624.3.
It's 6, 8.
624.
22.4.
624.3.
Okay. So most of the questions are simple. Okay, I'll just go over them. Predict the sign of entropy change for this reaction. Explain. Lead 2 oxide can be made by heating lead metal in air. lead metal in air, तो क्या बन रहा है? lead 2 oxide, Pb plus 2 O minus 2, right? Let's, this one is a solid, this one is a solid. अब बताओ, predict करो delta S. What is delta S? Negative, positive?
Negative.
और क्यों? क्योंकि gas moles are decreasing, right?
Decreasing.
Then you have तो वही कह रहे कि you first delta S is already calculated. I'll just go over this question. First thing is calculate the standard entropy of so delta S is already given. तो वो क्या होता है? It's product entropies minus reactant entropies. Now if it's product entropies minus reactant entropies, you take out the difference. There's only one thing that's missing, and that's the entropy of chlorine. ये last time हमने किया भी था, ठीक है? So you can just solve this equation. Explain why the entropy change for reaction 1 is negative. Negative, why? Because number of gas moles decrease. यहाँ पे gas है, and in your products you don't have gas, ठीक है? So the moles of gas, they decrease. अब यहाँ पे वो कह रहा है कि the enthalpy of formation of the enthalpy change is given. That's minus 640 minus T times what's the other one? Delta S. That is also negative. That's minus 225.7. I said this has to be less than 0 for the reaction delta H minus T delta S, right? So we care, why is it spontaneous at lower temperatures? Because of the two negative signs over here, this is actually positive. So at lower temperatures, this term will be smaller, the positive term. The negative term will be larger, so overall delta G comes out to be exothermic, okay? And why it's not spontaneous at high temperatures? It's not spontaneous at high temperatures because if you keep it high, the positive term will be much bigger and delta G will come out to be greater than 0, okay? So ये clear है? This example clear है?
Yes.
चलो ठीक है, कल बात होती है. I'll send you the worksheets for this. We're done with the energetics chapter basically, ठीक है? So I'll send the solved and unsolved. Try and go through the questions in that sheet, ठीक है? तो अब थोड़ा सा पूरा भी रिवाइज कर लेंगे. लेटेस्ट पास्ट पेपर्स खोल के ना, we'll try to do questions from the latest past papers. We did bits and portions, we did lattice energy, Born-Haber cycle, we did enthalpy of solution, and we did entropy, ठीक है? तो कल थोड़े से बड़े questions करेंगे, ठीक है? चलिए, okay everyone, let's talk tomorrow, ठीक है?
Allah
Sir,
Hafiz.
thank you. Allah Hafiz.
Allah Hafiz.